For all of you, I give my cordial welcome to the day, National Science Day, 28th February, which is being celebrated on the eve of the remembrance of Raman's effect, as well as in Kerala we have KRR Ramanathan's Day. Ramanathan is a famous scientist from Trivandrum, Palakkad. His birthday also is celebrated on the Science Day. So this day, this week, all over in colleges as well as professional institutions, Science Day is being celebrated. In the school, especially Atal Labs, tinkering lab has been opened, and the science has been imparted to the students and awareness program. Similarly, Vigyan Parivarta Paijoit, that is exploiting the science to the students as well as to the community, is being popularized in the day by Government of India in a big way. So unusually, I'll find a lot of interest among the students. Last 1 week, I have attended more than 10 programs. I have opened 57 Atal labs so far. And I find some interest is emerging from the students. On this occasion, Institute of Engineers Madurai Local Center also wants to celebrate Science Day by inviting an eminent speaker, internationally renowned person, our own man, Dr. Venkatesan, on the topic, the United Nations Decade of Ocean Science, the role of engineers, how the role of engineers play a vital importance in the ocean science in terms of ocean surface temperature, living standard, living animals, and the plantation of ocean, and the deep ocean exploration. About that, a lot of things engineers have played a role on this particular topic, ocean science, in which we are proud to have Institute of Engineers member as an international a renowned scientist. We invited him for giving a talk on this subject. The Government of India has given a major topic as an integrated approach of science and technology for the sustainable living. There is a topic they have given. Ocean science also is coming under the sustainable living, in which our speaker, Dr. Venkatesan, is going to give a talk. Once again, I cordially welcome Dr. Venkatesan to give a talk on this particular thing and enlighten us the hidden behind the ocean science to the engineering community. And I welcome you, sir. Thank you.
Narayan Swami, introduce பண்ணுங்க.
Thank you, sir. Thank you.
Udaykumar, நீங்க introduce பண்ணுங்க.
Yes, sir. Yes, sir. Please, sir. So again, good morning to all. It gives me an immense pleasure to introduce our today's chief guest, Dr. R. Venkatesan. Dr. R. Venkatesan is a scientist G and group head, Ocean Observation Systems at the National Institute of Ocean Technology, Ministry of Earth Sciences, Chennai. He served as a chair of IEEE India Council Ocean Engineering Society chapter from 2016 to 17 and is currently serving as a Execom member of IEEE OES India. He has 35 years of experience in the field of ocean technology and served as a regional coordinator under the UNEP Regional Seas program in Sri Lanka. He received an MTech from Karnataka Regional Engineering College and a PhD from the Indian Institute of Science, India, and completed a course in marine environmental pollution and management and received his Doctor of Science DSc degree for his work on the topic Moored Ocean Observatory. He is working on ocean observations and is also teaching ocean policy and ocean observation tools as an adjunct faculty in 3 IITs. He is honored by receiving 12 awards, including the UN Outstanding Services Certificate MTS Lockheed Martin Award. That is the first Indian to receive in Alaska, USA during the conference Oceans 17, organized by IEEE and MTS, and the National Geoscience Award and Tamil Nadu State Scientist Award, and is serving as a member of international and national level, such as a member of the steering committee of United Nations bodies such as GOOS, UNESCO, IOC, DOOS, and Ocean Sites, Smart Cables, Country Focal Point for JTA, JCOMM, the chair of the International Tsunamometer Partnership. In addition, council member of the Institution of Engineers India and chairman of the Institution of Engineers KLC of Institution of Engineers, and the founding chairman of Marine Technology Society MT in Indian waters, including for tsunami, early warning, and also in Svalbard in Arctic. He has been successfully organizing student underwater vehicle competition by NIOT and IEEE, and winning team is deputed to participate in the AUVSI competition in San Diego, USA. He has authored 3 books, 105 papers in journals, including IEEE journal, 250 invited talks, and has filed 6 patents to his credit. So with this short introduction of our today's chief guest, Dr. Venkatesan sir, I'm happy to be a part of the National Science Day organized by the Institution of Engineers Madurai Local Center. Thank you, sir. Over to you, sir.
Good afternoon. Thank you, Chair, and thank you, Secretary. Thank you, Mr. Rajamani, sir, and thanks to all the eminent engineers from Madurai. I hail from Madurai. ரொம்ப சந்தோஷப்படுறேன். Even though 2-3 இடத்துல இன்னைக்கு வரணும்னு கூப்பிட்டுருந்தாங்க, when Dr. Sivasubramaniam approached, I thought, okay, I must share. And purposely, I've chosen a topic which is far away from you, that is ocean. But the idea behind is to appreciate and what the ocean plays, and what we as an engineer have a role in this regard. And being a science day, I thought I will share my experience with all of you. With these few words, with the permission of all of you, I start my talk today. Is my screen visible?
Yes.
Yeah.
Yeah.
So today we will discuss about United Nations Decade of Ocean Science. What's the role of engineers here? Basically, we will brief about 70% of the earth is covered by ocean, and water, what we drink, air, what we breathe, and atmospheric conditions or the temperature what you have got is all from the ocean. Now today's day is very important, as it was rightly pointed out by the chair. It is the National Science Day is to commemorate the honors of Dr. C.V. Raman for his legacy discovery of Raman effect. You'll be surprised to know that today many instruments are available developed by engineers using this Raman effect for various scientific studies, and many more new scientific discoveries have come. What is science all about? It's the relation between the knowledge and the science. What is science? Basically, it is scientia, we call it. It's a knowledge. A definition of a science is basically a systematic enterprise that builds and organizes knowledge in the form of feasible explanation of the world. What is relevant to us? And that is because India, we have a large pool of scientists. Our budget is now recently increased. We need to think about how the science and engineers have commonality and play a major role. What is the role of engineer to the society? Do we need them? Why not scientists alone? Are engineers professionals? Is there a relationship between society and the engineering? Is the society better from engineering? These are all the answers we need to give. Scientists study the world as engineers create the world, and that is what is engineering is an application of science to the common purpose. It's often said that scientists use an instrument for his studies. There are 3 engineers behind that who understand the science and develop this instrument for making them to happen and to get the results. Today, even go to hospital, you have various medicinal discoveries. We say that yes, doctor has found this, I have this ailment, but all there are engineers behind that. who are not aware, we can call them unsung heroes, they understood the science. They understood the intricacies of the science behind it, and they developed it. So the main focus of the scientists is to develop the knowledge and the physical universe. Science is in the pursuit of the knowledge, in the sense that without any concern to the needs of the society, whereas the combination of the both is for us. The central focus here is engineering profession is application of scientific knowledge to meet the societal needs. Today, talk about the dam, you talk about storage of water, you talk about the power. These are all engineers are visibly seeing their major role to play in any discipline, whatever we call. Engineering connects the pure science with the society. Engineering, therefore, is a social responsibility. This is what Institution of Engineers talks about it, which was instituted more than 100 years ago, talks about the social responsibilities. Like IEI, we have many other technical society. Even IEEE, we talk about, the slogan says that connecting people, connecting engineers and serving to the society. So the technology should reach the society. That's what I would dwell upon in my talk in the later stage. So having social responsibility mean what? It means a commitment of the engineering profession to place the safety and interest ahead of all the consideration. So if you talk about the safety, again, the engineers need to design the safety instrument. There are even simple wall, you talk about that. These are all devised by the engineers. So engineers take into account of what is regarding, what is the consequence of the conduct, what is the well-being of others, and that requires engineers to take a determined effort to take the relevant facts concerning the design, development, deployment. Even if you look at the structures, what we have, temples more than 1,000 years old. I still remember my talk on the same science day in Annamalai University, where more than 3,000 students were present. I spoke about the engineering behind the construction of the temple there. And there are relevance to that, like we called about what we need. It has been well defined there. That is similar to what we have. We need to breathe. That talks about that, and lungs, and about 4 seconds once we breathe. That is an amount of on the dome you find number of golden plates, and the nails what it has got is linked to the nodes what you have got in the body. I spoke in length about that. So that is what we today we're trying to understand and think about that. Humanity is now facing the huge challenges in 21st society. The population what we had in 19th century was 5 billion. It crossed somewhere 1992, it crossed about 6. In subsequently, in a short span, we crossed 7. We are heading towards 8 billion. And added to that, in my own field, about 40% of them living close to the shore. So the energy, food security, competition, scarcity of the natural resources, all and related to the climate change. We are seeing the role of climate change and the vagaries, and I will show you about what challenges the climate change is giving to us from the ocean side. Engineers of this country will face these consequences throughout the career. So there is a definite need or an importance where engineer skill is required. There is skill development to talk about the sustainable engineering systems. I was in a selection of projects, or IIT Bombay has got a new technology innovation hub. There are more talk about how to store the energy, carbon storage. There are more to talk about. The IoT can get into the agriculture system. Storage of onion. You will be surprised that 40% of the onion is wasted in 3 months, July, August, September. We have the largest produce, but it gets wasted. Here comes the role of engineers, where we can develop sensors and see that when it gets rotten. There are 3 ways the onions can get rotten. One is by softness, touch, another one by smell, another one by appearance. So the engineers have to think of different type of sensing methodology and help the farmers so that we don't waste these onions which is being produced in a larger quantity. So that is what different projects are getting evolved. Latest technique and technology is being used. Now, to overcome these challenges, unsustainable pattern of consumption and production, because we are trying to change the habit of the people, that is not so. Everybody wants comfort, everybody wants, there is a need growing up, energy requirements are going up, but do we have the resources? Natural resources are depleting. The Paris Convention talks about 30% by 2030, we have to come from renewable energy. Are we prepared for that? Here comes the role of solar system. Nobody would have expected that per watt it was about 20 rupees. Now it is brought down to few cents. That is what this technology talks about that. But again, there is a sustainability over there. How do you dispose of these unused system or the waste or anything? These are all something crop up even in the ocean. I am part of a United Nations committee where we are working on a climate or environmental part of it. We don't need to dispose of these equipment which have been used. So there is one side there is a need, another side technology development is happening. Third, we need to think about sustainability and the air quality. Yes, it is really changing. We see quite often what happens in the Delhi. So health conditions get deteriorated. The COVID has really brought out an importance about that. So the sound manage of chemicals and the life cycle and the hazardous waste. Here, engineers need to play a major role in you. Okay, you produce chemical. How do you dispose it of? So some of the things like which we need to talk about: water and sanitation. The water consumption or the requirement is going up. However, the water is being wasted in a different way. The sanitation part, there are technology need to be developed. Energy, promotion of renewable energy, as I said earlier, energy conservation, energy efficiency, health and agriculture. So biodiversity protection is another important thing. So the one side, the sociologists and the biologists, they cry about large amount of species getting extinct, but we need to think about so that our behavioral nature gets adjusted to that. So there is a urgent requirement for the scientists and engineers need to come together. In particular, when I talk about marine scientific research and innovation, the young generation need to get involved and they need to act together and they need to evolve. So this is what I take classes in IIT Madras on ocean policy. I have a separate lecture. I talk about the Sustainable Development Goal (SDG). I'm glad to say that many of the colleges, engineering colleges in Tamil Nadu, they've taken SDG goal as a part of the curriculum, and I was also involved in setting up curriculum and making this part of their habit. And we are also in Institution of Engineers in Tamil Nadu chapter. You all know that we are involved with Dr. Sivadanapillai and Dr. Anadari and Dr. Velraj as part of a committee. We are developing 1 trillion economy document where the engineers can play a major role. Here comes again sustainable development. We need to look at all these aspects, particularly SDG 14 talks about life below water, that is the ocean. I will talk about it later. There are 169 targets. Even Tamil Nadu government has got definite target pattern that need to be achieved. But if you talk about sustainable development, there are 5 P's involved: people, planet, prosperity, peace, and partnership. There were Millennium Development Goal until 2015, but the Millennium Development Goal were confined to only to the developing countries, whereas SDG talks about developed and developing countries. All have got a common footage, and all need to have to cut this 5 P's factor, one of them. Now, the role of engineers in SDG could be the raw material, the energy part, the battery. You talk about the lithium battery, you use a lot of mobile phones using rechargeable batteries, and cell design, cell production, and recycling and reuse. So a lot more things need to be discussed about that. I will not dwell due to paucity of time. I will slightly switch over into the today's topic about oceans, how the oceans play a major role, and what need to be done, what is the current status, what is the role of the countries have come together in the United Nations to talk about the importance of the ocean. Now, as I said earlier, the breathe what you have got, we owe to the ocean because that provides clean air. Added to that, the temperature, if the most of the amount of carbon liberated by the transport sector is absorbed by the minute microplanktons on the ocean, if they do not exceed, the earth would have been warmer. And also, the ocean is under threat. The humans thought that ocean is having a large amount of carrying capacity. We discharge all our waste from the thermal power plants or many other resources, ship waste, they all getting into the ocean. There are regions which are talked about, they call the IUCN has declared as a dark zone or a black zone where there are no animals exist. Large amount of fishes are getting destroyed, but we need to look at this, the land-based resources and the seabed activities. There are mining which are taking place, deoxygenation, that is oxygen depletion is happening in the ocean, and also ocean acidification that is due to the climate change. All these affecting the animals living over there. If you look at it before the pre-industrialization by 1950, before the Second World War, there is not much of such activity in the ocean, and all these animals were living, they were very happy. As we develop technology or the engineering expertise is increasing, the population is growing up, and the humans start developing tools by which you can exploit or explore these resources, now that is under tremendous threat. This just gives you a nice picture of a breath. This again, now take another breath. Every second breath you take comes from the ocean. You will see these pristine animals close to you in Gulf of Mannar. The Robert Ballard is the one who has discovered the Titanic shipwreck. You can see the scuba divers. So if you look at all these activities, the human land-based activities and the extraction of the resources, depletion of the fisheries, acidification of the ocean, as I said earlier, all have got adverse effects. You have seen the pristine condition, how these marine animals are living over there. Keeping this in mind, expecting the population to grow 9 billion by 2050, the countries have joined together in United Nations and they have declared that once in a lifetime opportunity, they found decade of ocean sciences for sustainable development from 2021 to 2030. The activities have started from last year. Every state or country we have our own. The committees have been formed, activities have been initiated. There is a major thrust now to bring an awareness or bring a policy level so that these ocean resources, both living and non-living resources, can be preserved for the future generation. To touch upon, I thought I will talk about plastics because certain topics, if we talk too much about the ocean, that may not be linked to Madurai. This is one thing, even though you are in hinterland far away from the ocean, the activities what every one of us are doing is getting back into the ocean, that effect is seen. The major amount of plastic is one material which came into existence just 4 decades ago. Now, large amount of plastic or plastic debris are getting through the rivers to the ocean. Now, once a marine plastic reaches the ocean, it gets, even you'll find a lot in the beaches, they get disintegrated and they become microplastic and nanoplastic. They all remain. I'm also a PA for a project where we are collecting data from the surface ocean and midwater column on the seabed. Many of them have settled down on the seabed. And as an engineer, we all know about bonding. They are all covalent bonded structures where the basic molecule linked to the carbon is covalent bond that remain as it is. So microplastics or a nanoplastic, you would say that plastic is disintegrated. You are not seeing visibly, but in the microscopic level, they still remain forever. This is what when you talk about carbon footprint, the plastic footprint, what we are leaving to the future generation. Even in one of the TV interview I had spoken, this is what did not exist prior to our the presence. After our birth, we brought technology, we brought this marine plastic and the plastics which is reaching into the ocean. Now, when you talk about the other side, the plastic manufacturers, they say that 30% of the GDP comes from us. Because today packing industry or any other activity, anything automobile sector without plastic, there is nothing exists there. Do you have alternate material? That is what engineers we need to think. The researchers have to start working to develop an alternate material. We can always talk about the detrimental effect of plastic, but unless you find an alternate material, the usage will continue. This is from the accumulation from the rivers or the beaches, and the left top picture talks about once it gets into the ocean, there are surface currents, there are also subsurface current, there are upwelling phenomena. The ocean is so dynamic when the earth is evolving. There are larger, more activities which is happening that makes the whole plastics get distributed in the different part of the ocean that can reach the different coast. This is the debris which we have recorded in using underwater remotely operable vehicle in the deep ocean, the Mediterranean Sea. Even the plastic is seen in the deepest ocean is called Mariana Trench, which is about 11,000 meters. There are plastic which has reached over there. So we have put our plastic footprint everywhere, and that is what is a challenge. Even this is it's very sad to see these marine animals they consume. Recently, we have one of our survey we found a large fish close to about a meter. When it was slit open, we found Coca-Cola cap over it, and these are all the consists of the packing material. You find like Coca-Cola or that has gone and that gets integrated, and this is the way the animals get entangled with the nets. This is my first paper. I think this is the first ever paper published when I was heading a group called Ocean Science and Technology for Islands. In Nicobar Islands, we found a lot of plastics. We published in Current Science Journal. If you Google search it, my name, you'll find. Because this has nothing to do with the tribals living in that region. This was mainly due to the passing ships, which is a major ship traffic towards Malaysia and Singapore. Whatever they threw, and because of the ocean surface current, it has reached on the Nicobar, and the tribals, without knowing that they were using it. And today, many more things have happened, but still, this activity is continuing. Ocean current plays a major role to bringing back these debris into that. With all these things, when you talk about the natural hazards, for us alone, we have Bay of Bengal and Arabian Sea abutting our Tamil Nadu coast. We have Bay of Bengal, and the other side is an Arabian Sea. The cyclones forms 4:1 is the ratio between these two. That's mainly because of the conditions what we have got. In Arabian Sea, there's a definite monsoon pattern from June to September, October. In the case of Bay of Bengal, it's mainly because of the low pressure formation that is leading to the cyclone and the river rain comes over it. So now these have got a larger role to play. I can speak a lot, but today I will short to say that the stratification in the water column by freshwater influx in the Ganges Brahmaputra, which is peculiar in Bay of Bengal, is not happening in Arabian Sea. That is leading to the large amount of low pressure and cyclone formation in this region. This is what this UNDGATE talks about that. The vision of the UNDGATE is develop scientific knowledge, build infrastructure, foster partnership for a sustainable and healthy ocean. I was part of this planning committee, and when I visited UNESCO, I was in Paris. When it was evolved, we discussed about it. I was also in the GOO steering committee member. Later on, I was chair for all over the world. 13 regions, I was a chair. We had given our own input. Finally, it was approved with the expert committee, and today it has come into force. Now, this is linked to the sustainable development we have seen earlier. There are various activities which is happening. The middle, what you see, the regional seas UNEP, where only I had worked earlier in Sri Lanka. I was a regional coordinator for South Asia, like India, Sri Lanka, Bangladesh, Pakistan, Maldives. I had visited these countries to work on this regional seas program. So this encompasses everything. The law of sea is the one which is located in New York. I had visited that. BBNJ is beyond the national jurisdiction, outside the exclusive economic zone. How do you conserve the resources? That is what BBNJ talks about that. Now, what they have done, they have evolved the ocean, what we want. There are about 6 themes have been evolved: clean ocean, healthy and resilient ocean, productive ocean, predicted ocean, safe ocean, accessible ocean, and inspiring and engaging ocean. My own experience in the case of predicted ocean, number 4, there is a major program launched by the German government. The Chancellor of Germany, she was present there, and I was invited to be a panelist, and I gave a talk and shared our India's experience on how we are predicting cyclone, and that was a really honor for us being invited to talk in that. Today, Safe Ocean is another lab they call Ocean Laboratory. Globally, about 48 hours, a different part of the world, they got a different activity. Again, for Safe Ocean, I got submitted a program through another scientific group in US where I'm a member. We call air-sea interaction, how the interaction between atmosphere and the ocean is really making, like we talk about cyclone, that science need to be developed. So we have a program for island nations, which I proposed, and yesterday it got accepted. I'm working on it to conduct this event on April 5th. So this is what anybody, even please go through the website, student whoever is listening, or anybody, there are enough videos are available. Last month, there was a One Ocean Summit in France, which was launched part of this activity. And I was also again invited there, where I had presented how we have developed a new technique by using fishing vessel for ocean data collection. So that was accepted and present. I was made to present. So there are scientific breakthroughs are expected. There are mega projects being evolved, all linked to the societal application like coastal zone management, coastal risk reduction, adaptation mitigation, and marine spatial planning and aquaculture and convergence of policies. Last week from 21st to 24th, we had a Ocean Decade. This is IEEE and Marine Technology Society jointly. They organized. We conducted first time in India in IIT Madras. Our institute was involved. I had once exclusively session on climate panel. Whoever is following me in tweet or LinkedIn, you would have noticed. This is with NOAA, the chief scientist of NOAA, and I could bring the Prince of Monaco, Prince Albert, as well as the minister from Norway, and my own colleague from WMO, World Meteorological Organization President Michel Jean, and the World Bank, again my good friend. They all have come and participated with IIT professor and Dr. Akhilesh Gupta from Department of Science and Technology. Because recent IPCC report, which was released about a few months ago, there are 10 cities expected to be affected by sea level rise in 2100, where Chennai falls one among them. So that's the reason in the whole panel discussion I had evolved a team called C4, Climate Change, Coast and Chennai. What type of technology and engineering solutions are required? Sea erosions are happening, sea level rise is happening. That is what IIT professor and many other Indian experts have joined. They have shared the experience. Now, disasters, if you look at it for our own coast, we have cyclones, storm surge, floods, and tsunami. I had given a very detailed talk earlier in IEI Tamil Nadu State Center. I'm not going much in detail. I'd like to say that these are all some instruments. I will straight away coming into our own NAOT activity where the engineers have played a major role. We deploy this instrument and with a surface buoy system and anchored from 20-meter depth to 4,500-meter depth. Recently, we launched at 5,800-meter depth. That's 5.8 kilometer below the equator in Indian Ocean. First of its kind that is providing data. Even that tracked one cyclone going to Mauritius, so we could do that. So this is advancement of technology, which is really helping us to provide information or early warning on cyclone. One of the many things. The main important component comes from the modeling. India has got a supercomputer related to that. Not only that, we have different instruments, profiling, drifting. We collaborate with many other countries. We sail on board the ship. We also use a commercial ship. So it's all gamut of activities. In fact, few of them got affected due to COVID. The experts from abroad, they are not able to travel, and that is really affecting many of us. However, in India, we have our own observatory, and they are working satisfactorily. We have a left top on Tsunami Boy early warning. We call Tsunami Boy System, which is also working fine. This is another underwater robot, which profiles. It's again the engineer's input for a great scientific data collection. This dives down at 2,000-meter depth by just wearing 50 grams of seawater. Once the 50 grams is pumped out, it becomes lighter weight. It pops up to the surface. Again, 50 grams is taken in and it dives down. So in this way, nearly 3 to 4 years, in a span of about 20 days, once they come to the surface, they dive down, collect data, again transmit it. So in this process, complete from surface to 2,000-meter water depth, temperature and salinity. Today we are talking about dissolved oxygen. Many other parameters are collected. When it comes to the surface, it transmits data. Beauty here is for diving down and coming up, it doesn't use energy. It is used only the variation and buoyancy. Only for data collection, what you have seen on top, for satellite telemetry, very minimal amount of data is transmitted. Once this life is over, it gets lost. It will remain maybe on the seafed or maybe drifting. So this we have currently 3,000 such floats are available. This is one of the successful program globally. Many countries are involved. Anybody interested to get this data free of cost, it's available in our sister institute in INCOIS, Hyderabad. These are all in coast. We have installed in our own institute, Andaman. Last 11 years, it's working. One of the toughest region. The engineers from Port Trust and Port Blair, they told me very difficult to deploy, but we have devised our own methodology. This picture is an underwater picture, cross section by our divers. They have collected, and this is to show you how the structure remains. There's also a growth of animals. and sometimes we find sea snakes close to Andaman. They all come and settle down over there. Complete picture I'm showing you. There are about close to 52 such systems are there. Very complex, very expensive. Last 20 years we have been operating. Every year our budget is about 40 to 50 crore to maintain that. For tsunami early warning, we have exclusive systems in Nicobar as well as in Makran region. We also collaborate with American. There are 25 of their systems involved. And jointly, we have developed a portal, India and US. We are sharing the data so that the global community can use. Because the hazards or cyclones, whatever we talk about, that there is no political boundary. In Indian warning is for the region. Not only India gets benefited, neighboring countries like Bangladesh, or even up to some extent, data being shared with the Middle East. Because nobody else has this technique or expertise what India has developed. And you all should be proud that on the moment of National Science Day, this is what is our strength. This basically comes from the basic 12th standard science and what we have learned. That has helped us to bring us overall as an engineers to play engineers role and the scientists to work on scientists and the modelers to develop modeling tools and the computer specialization who work on the prediction purpose and oceanographers and meteorologists, all of them come together for a common cause, reaching the society. This is what is the Data Reception Center, which I myself have developed in our institute. This man 24/7, one of its kind. Even countries like US, I'm proud to say that they want on a technology transfer basis. We are trying to provide them. It doesn't show not only the data, it has got everything about calibration and the serial number of sensor, who was born, when, what. Every year, about 200 days, our team sails. Even now, tomorrow, they'll be sailing from Goa. They will come back after 30 days. So this is what is our experience or the work involved, because from quarter pin to container, we have to carry before sailing. That much amount of planning. Many of you have worked in the government setup. We need to follow strictly the government norms to procure or service this instrument. And we are a very small group. When we sail out, we can send only about 6 to 7 people. So they all have to share, could be electrical or electronic, mechanical, but all have to come and work together. That is what team building. Fortunately, I have a very good team. They make it successful. We have a data return of about 90% above, which is very highest in the global level. That's mainly because so many people work. We have a best practice method. We test every sensor here. We interface it and take it on board. It means dismantle, again assemble it. The whole process go in a very systematic way and dedicated way. And this is one of the module what you have developed in the reception center. You can see in the right side panel up to 500-meter deep sea bed close to the deep water we collect data. They all work on a induction principle. Some of your electrical engineers, they don't have the electrical cable laid. The induction principle in the water column is used for transferring the data from bottommost from 500-meter depth. We have about 20 sensor in different depth level. It comes to the surface buoy system. The display shows last transmitted data. It is like a drama. The person, the group of people have to enact in front of people, whereas in the cinema it is recorded. It's not. It's a case of drama here, where the system has to function at sea. Then only I can show that yes, data is received. If not, it will be showing 0. That is what is the strength. We use a lithium battery, what you see on the energy part. In addition to that, we also have got a solar panel. We have designed peculiar to our own condition the changeover system, because sometimes the solar panel gets stolen and the changeover is to the lithium battery, which is hidden inside. That subsequently comes into the picture. In the case of tsunami warning, system has to work 24/7. If doesn't work, then we get a parliament question and it is taken very seriously. So everything, I'm not going much in detail. We have got redundancy, and that makes a whole thing. We also developed a new thing called rapid mode, which is our own engineering design. The sensor senses when there is a wind speed increase or the sudden drop in pressure, it starts pumping data in rapid mode. When the condition comes back to normal, it returns back to normalcy. This is you have filed a patent. This is sort of something new to you. Sitting in Madurai, you may not know. We are tracking ocean, any cyclone far away before it lands. You will be seeing from the paper, a newspaper start telling 2 days prior to that, but sometimes 6 days, if at all, the cyclone formation much earlier. There are about 6 parameters required for prediction of this by the Indian Meteorology Department. Close to 3 of them come from the ocean. As an engineer, we should be proud that when these harsh conditions, when the wind speed is 200 kilometers per hour, and the ocean current is strong. Is in all these conditions, the system what we have deployed and worked and provided data, including the recent cyclone, Yas cyclone, which was last May traversed through that. We had this data. This is to show you, seeing is believing. I'm just showing you a few buoy systems which have tracked during the cyclone and the Varda cyclone, which hit Chennai coast. We have continuous data which are provided in a real time. Some more improvisation we have done. I'm not going much in detail. This is what is recent challenges, what we face. Normally in the month of May, you don't find cyclone. There are two consecutive cyclone, Arabians, Bay of Bengal. Even in 2020 and 2021, we had these cyclones hitting over there. That's really a challenge for the administrator, for the people to be evacuated or the conditions to be evolved. Here are all these cases, the prediction was perfect and the landfall was perfectly told. This is what is the collective effort of we call Earth system approach, where ocean and atmosphere, along with hydrology and cryo, all are monitored together to safeguard the nation. Again, a picture to show you. Then we started working on indigenously developing these technologies. This is one of our own system made in India. We reduce the cost drastically, and they are all working fine. The challenge for us, when you develop it, we can service only once in a year, so that whatever you deployed, if it malfunction, we need to go react to that. So there is a rigorous testing methodology we evolved before we do the indigenous product. They all gets qualified. This is to show you how the collaboration between India and US, as I told you earlier, the American ship visited Chennai, and I had organized, I was a PA here. The basic knowledge, we also learned, they brought special instruments, and we had students on board the ship. I had organized about 15 training program, and the final product is to learn or understand about the science, and that is what we have tried to do that. This is one of the instruments which is used where we call futuristic ocean ride. We are also buying an instrument called autonomous underwater vehicle. This is also used for many of the strategic applications. This will help you to survey and collect data even close to the seabed. I'm not going much in detail. There are many more things we are doing. This is to show you, as an engineer, we develop product, we transfer the technology, we file patents in spite of regularly servicing it and sailing on board. That's the main purpose. In addition to that, we have the passion of making our own product and transferring to the industry. Like L&T has taken over yesterday another industry, and they all will be providing to not only in India, to the neighboring countries. We have a definite pattern by which even under the Make India program, we provide this. So it's with the limitation we are doing. If this team is bigger, it would have been much possible. These are all few patents. Some of them have been awarded, and some of them are in the process of getting awarded. And another experience we have is going to Arctic, where India has got its own presence. I visited there in 2014. You'll be glad, from Madurai, nowhere near to the coast. I went up to Arctic and stayed there for 15-20 days and deployed and designed by us. In my own design, I had an opportunity to deploy the system, which had to withstand the freezing conditions in Arctic. And I'm glad that every year our team goes in July, service and redeploy back. The original design, what I had evolved, still working satisfactorily. This was also one of the IAS examination question by under UPSC. I had named it of INDARC, Indian Arctic Observatory. This abbreviation was asked in one of the question in UPSC exam. See the continuous data. This all come. It's not the instruments we are buying from abroad. That doesn't matter. But when you interface it, you need to check and do it in a short span, because we get only few hours by the Norwegian ship to go and deploy. We have to fly through Norway to get into this location. Very harsh conditions, and also the polar bear, just such challenges do exist. But in spite of that, last 6 years we have good scientific papers. One recently in the Nature on the acoustic measurements. Another one linking Atlantic as well as the Bay of Bengal. We have published paper. And this is a Tsunami Boy System, which works to, when the tsunami wave is traveling, we need to measure the water column change in the water column height. That originally design was done by USA, but I am also chairman of the global committee where technology development aspect we discuss. Out of 13 countries, India is one which has joined. This is to show you the very recently, Tonga, close to that, such a tsunami event occurred. So this is really an eye opener for us. And these instruments deployed by the US Boy systems, what you have seen, that's the only way to capture data. But the satellite data doesn't penetrate below 70 meters. However, such in-situ observation close to the seabed is really important. Here again, I am as a chair of International Tsunami Partnership. We are trying to work with many other industries because this is one way earthquake-based tsunami we can predict in this technique by water level variation. However, the tsunami do occur by the land-based earthquake as well as the landslide which happens on the seabed. So the Sundar Pichai CEO of Google has recently tweeted that they have developed a technique by which they can detect cyclone and the earthquake under sea. That's mainly because you know very well today we are talking in internet. That's mainly because of underwater cable which are laid on the seabed. There are about more than 1 million kilometer length of cables are there, and about 16 cables are owned by Google themselves. It costs about $16 billion. They have developed a technique by which the optical optical the cable is used for transferring the data. In the end, you have the optical to electrical optical conversion take place. That is done by Nokia. Recently, our Prime Minister has launched the cable between Chennai to Andaman, so 400-kilometer long. One more is getting evolved, Cochin to Kavaratti and Lakshadweep. But what we thought as a scientific group, I am one of the task force member of 3 UN bodies, that is UNESCO, Intergovernmental Oceanographic Commission, World Meteorological Organization, and International Telecommunication. IT only allows all the frequency for all the satellite or any other application. That's the highest body. We all joined together, a few experts from scientific group and also experts from the industry. We discussed whether we can attach sensor to that, because the conventional sensing methodology only in kilobytes we get the data. Moment you have sensors attached, that even in seconds level the data could be pumped, because the data transfer rate is very huge. We have a small success, but they ask a question: do your sensor work for 25 years? Because the cable life is 25 years. That is what we are taking to the industry. I'm also a member of the UNESCO IOC as well as a Marine Technology Society industry dialogue, where with all the global industry we are discussing on many other aspects, because the sensor part per se is not much is happening in the ocean when you talk about measurements of ocean parameters. So coming back to another important program, knowing all these things, Government of India has launched this Deep Ocean Mission, wherein 4,800 crore is allotted to work on various aspects of ocean, where the engineers play a major role. Our institute has got larger thrust by work on deep ocean mining or desalination, as well as ocean thermal energy conversion. There is also a marine station to be established in Goa. Many other aspects are being discussed. We will be developed in the due course. This is to show you where the mining group we call Deep Sea Technology Group in all over the world, all over the Indian Ocean, they have visited and they have deployed their remotely operable vehicle for various aspects. So this is what is just to get a feel on a National Science Day, how Indian science and oceanographic or ocean technology is improved, and you'll be really interested to know more about it. Now you can Google search the keywords or the terms what I have used. That will really help you to understand more and more about it. What I spoke is very minimal. There are many more things which I cannot cover in a short span. This is what I said about cable network. That should be the next generation, where more sensors are required and the engineers need to play, and that will, because connecting an instrument is not, it's very difficult, because then you see what ingression can affect the whole network itself, which is costing billions of dollars. However, they are very confident they can always seal it, but the oceanographers need to develop sensor to that. Next thing is some of the UN bodies which are changing the due course. I am nominated by the Government of India to be part of World Meteorological Organization in Geneva, and wherein we are discussing about Earth system approach on climate change, research to the society, think about water, ocean, as well as hydrology, like river water is coming, lakes, including cryo, which is happening in the polar region. And tonight I'll be chairing this session. IEEE USA, I'm part of their team. We have proposed an ocean sciences meeting to talk about engineers' role in the case of ocean sciences. So first time they have accepted. Normally the ocean sciences meeting is fully occupied with the science component. All over the world, globally they join together in person. This time it is in Hawaii. Unfortunately, we are missing that chance and we are conducting through. Herein I proposed a theme for island nations, and you can see the abstract. There are very much limitations, and the fees are quite high. In spite of that, I got a good response for the theme what I proposed. Today 7:30, 8:30, I have to conduct this session and bring out a report which we submit to the OISM over there. And this I was invited, I told you, to the German government, and where I had spoken about weather, climate, and prediction part, and how India we evolved, whatever I said on the observation, what is the futuristic reaction to talk about that. And this is in the GRA, Global Regional Alliances, which I chair. You'll be proud to say there are only 2 or 3 Asians, and I could survey nearly 6 years, the meeting in Colombia, and wherein we could discuss, and they really appreciate what the technology or the science component India is bringing to their platform. And I was part of many other discussion or the framework what has been evolved. That is given in exposure in the United Nations level, how the simple science getting evolved into the policy aspect. With all these things, I have a smaller role to play, and we all can be proud of that. After the Gaja cyclone, we went around to see different places near to Madurai, Pudukkottai, Nagapattinam, and Trichy, Tanjavur district. When we visited, we found more than 3.5 lakh people homeless, and a lot of houses destroyed, and coconut trees. Then initial relief to our office, we gave a small relief. Subsequently, I got an idea to provide a tree plantation, and that is really picked up very well without my thinking. It went on up to about 20,000 coconut trees, about close to 20 lakhs from different sources. And I took a plan of going to the government schools, because that can reach we can motivate the children. And about 30 schools I visited, gave a talk on these aspects in Tamil. நான் சொன்னது என்ன, தமிழ்ல படிச்சதால முன்னேற முடியாதுங்கிறது ஒன்றும் இல்லை. நானும் தமிழ்ல படிச்சா முன்னுக்கு வந்தேன். இவ்வளவு தூரம் பேசினதுக்கு காரணம் பேசிக்கா தமிழ்ல படிச்சதுங்கிறது அங்க சொன்னேன். And that is what Dr. Anadri also tells, that நம்ம வந்து தமிழ்ல படிச்சதால ஒரு ஹிண்ட்ரன்ஸா தெரியக்கூடாது. And whatever we know a little bit about science, with these few words, thanks to the IEI Madurai for giving me this opportunity. And sorry that due to pandemic I couldn't travel, come and personally meet you all, and I'm sure that this will give an opportunity to discuss more, and I'll be glad to answer any of your questions. Thank you very much.
Thank you very much. Shall any question? Anybody having any doubts to be clarified from scientists? You can raise this one. I have 1 or 2 points. I will ask at the last.
Any questions, please, from your side, which you want to me to answer, or which you want clarification from my presentation? It may not have covered in depth, because I thought I'll just give a brief about some of the topics. It should be wide open for you to read more or get yourself equipped through many other resources available online.
Dr. Venkatesan, can I ask a small
Please.
It was really eye-opener and a lot of information, many information you have given. And thank you very much for this wonderful presentation, really. The informations given in the slides are much more than what you speak. And if you can share it with us, we can go through it leisurely. And is it possible?
Sure. I'll send you that. I'll send you a file.
Thank you so much, sir.
Yes, sir. Rajamani sir knows everything. Whatever.
Very good presentation. I have no comments on this, because you are always doing it in an explanatory way.
Thank you, sir.
Dr. Venkatesan,
வாய்ஸ் குறையுது.
குறையுதா? இப்ப எப்படி?
கொஞ்சம் பக்கத்துல வச்சுங்க, மைக் பக்கத்துல.
How is it now?
better, but still not full. பரவாயில்ல, கேக்குது, சொல்லுங்க.
I have two questions. One is unmanned underwater vehicle you mentioned.
Yeah.
Nowadays, there's a requirement coming from drone technology. How to use the drone technology in the underwater so that they can quickly transport the data as well as packages to the various parts. That is one technology which whether any attempt has been made in the research. That is one thing. And the second part is about the energy. You have covered ocean thermal energy, the thermal energy conversion, OTEC.
Yeah.
About any work is done in India.
Yeah.
One is ocean energy, another one is tidal wave energy, third one is ocean thermal energy conversion.
Sure.
Any activities being carried out in India, any of the NIOT center or NIOT research station are doing it, that you can mention.
Sure.
Please.
First question on drone. Yes, we call it in a different way. Autonomous underwater vehicle we call, and glider. I had shown you about one of the instrument which is diving down, that is Argo float. Similar to that, there are gliders which will glide down. In ocean, the difference is the drag. In the air, the drag component is very minimal. Here you have a drag. In addition to that, ocean current and the wave, that is making it complex. The challenge is that the communication underwater is only acoustic, and it has to come to the surface for any microwave communication through satellite. So with this impediment, we are developing this instrument, and even I am conducting every year on autonomous underwater vehicle competition for students, and the winning team through NIOT, we send it to San Diego. And I'm very glad that there are two startups which have come. One is most successful. More than 40 people are working in, they started in IIT Madras. Today they have moved out to their own campus. They're doing a lot of underwater survey work in Middle East, and $160 million they have mobilized recently. So these are all underwater autonomous vehicle, we work on it. In the case of AUV, autonomous underwater vehicle, is slightly what you say like a thruster it has got. It is used for even defense application with the torpedo. But being driven by the battery, because of the energy source limitation, normally AUVs are 8 to 10 hours. Even it can go to deep, but the travel time, the sailing, diving it down and diving up, taking into account, 8 to 10 hours is maximum. Thinking about it, you have an underwater charging station where it can dive and maneuver and charge and go back. Fine, these are all on the theory. Practical application with the deepest AUV, which we are buying, is about 75 crore from, it's a Kongsberg company, Norwegian company, which will be landing this month, our institute, and we'll be deploying for a strategic application for claiming some area underwater, which our PMO is really asking for it in Indian Ocean. So that will give us the expertise on operating it. One is design, another one in underwater operation. These instrument is really tricky, and we have trained our engineers to operate this instrument and maneuver them for the AUV purpose. This is as well as a drone technology, but still it is getting evolved. And I also work on biomimicry. I didn't touch mimicking the ocean. We have made a robofish, and there is a Virginia Tech University. They have an office in Virginia Tech, India. I mean, their research advisory board. They have developed underwater jellyfish, duplicating that. But the challenge, you know very well, the motors, you don't have a long thrust motors commercial available to duplicate that. So that is the one thing which is really an impediment for us to duplicate straight away from the ocean. When you take it in the pond, it works. When you go to the open ocean where there is a strong current is there, we don't have that much. Then you can imagine in nature how these animals are conserving their energy and sailing it in that condition. But still, we are working on that regard. As far as the VOTEC is concerned, I was a project leader way back in 2000, I'm talking 21 years ago. We constructed the first ever VOTEC plant, VOTEC barge we call, in Goa shipyard in Goa. We towed it and off Tuticorin we tested. We had a failure, small challenge. It is not due to the technology. We have to draw the water from 1,000-meter depth. The ocean, the temperature difference from surface to deep ocean at 1,000 meters, 4 degrees. Surface is in our water's tropical ocean, you get about 29 to 28. So you need a delta T of 25 degree. Using ammonia as a working fluid, you need about 13 degree to vaporize, or to 23
Priya.
to vaporize and 30
Priya.
degree to condense. Everything we have done. But connecting 1 kilometer long, 1 meter diameter, high density polyethylene pipe, we have welded the pipe also into Tuticorin. When we connected, we as a small scientific institution, we don't have big machineries or equipment. There's a larger funding like ONGC or any other offshore company can offer. Because of that, we failed. Subsequently, we didn't take it up because of funding constraint. Now it has been revived as a part of Paris Convention 2030. I mentioned. Now this is part of an activity slightly modified. We are doing it. You know very well. There are 3 desalination plants offshoot of this water we have installed in Lakshadweep. One is working almost from 2005, last from more than 10 years, 15 years. It's working. This is called NAOT water, producing 1.2 lakh liter. We have expanded from Kavaratti, Tagati, and Minikoi. There are 6 more islands it is coming. Now we thought OTEC using this pipeline itself, from 600 meter we do the desalination, extend up to 1000 meter and produce energy, demonstrate that should be used for the pumps what is being used for this application. So that's the one thing OTEC we are reviving. And we are also trying to use an open cycle. In the closed circle loop only we need ammonia. Open cycle we can avoid, but the turbine size become bigger. So we have done some model studies on the turbine part of it. The heat exchanger is basically a plate heat exchanger. We have done some good work on that. Titanium plate exchangers could be used. So I'm soon that 3 to 4 years we'll be able to do that. We have done on wave energy of Vizhinjam, and 10 years we have collected the data. Wave energy challenges, we are close to the equator. As long as we are close to the equator, the wave height may not be so much sufficient for a sustainable way to conduct this wave energy production. We get in kilowatt region, the maximum about 55 kilowatt we got. And again, it's seasonal. During monsoon time, it's much higher. And current, yes, we have tried in off Andaman, it's small model studies. Tidal variation is possible. There are studies being done in Gujarat in 2 places, Gulf of Cambodge and Gulf of Gulf of Cambodge and Gulf of Kutch. And offshore wind energy is picking up. In Niue is an institute, they are working and we are helping them. We have installed a single point mooring platform to measure the wind profile data. That is 50 kilometer stretch of wind profile is required to be given to funding agency. That's the first and foremost thing. Government has brought out a offshore wind energy policy. And Ramnapuram, we are not able to install that observatory. Once these things are done, definitely you'll find more amount of wind farms along the coast. Only in these 2 places, it's more feasible. Other locations are being looked into that. So this is what under the blue economy, and there are a lot of discussions taking place on the energy component. I just provide you in a nutshell.
Yeah, as you said, it is in a hybrid mode. On deep sea, you have the
Her voice is low.
Your windmill, wind and ocean energy put together. Is it clear? It is audible?
No, slow only, but low only still doesn't matter. Yeah, wind and ocean
Wind,
energy.
in British, they have a wind as well as ocean energy put together and a hybrid mode they have. As I asked earlier, OTEC, Ocean Thermal Energy Conversion, instead of using ammonia, in US they have used Freon. Freon they use, by which their turbine size and other thing they reduced it. That is another part.
We know in nowhere else they continued this VOTEC. In Hawaii they have tried. We also collaborated with them. Freon gas, why we have chosen ammonia is Freon has got its own limitation on the efficiency part of it. And to ammonia, again, we have a challenge of handling it, particularly in offshore. It's very difficult. That's the reason we thought in Kavaratti place like remote area, we'll try with open loop. In the case of whatever you are talking, one important thing on wave is close to Portugal coast, you get a lot of wave. That's the reason more feasible for Europe, particularly in Portugal, because of the natural condition they should be able to do. They are most of the wave, more than 1,000 patents are there, ideas are there, but you call it about per kilometer length, the wave energy potential we call it. It will minimum we require 10. Keep it with you, we have less than 7. This is what is natural condition. So unless there are newer tools and technology which makes it possible, like solar, we had 20 rupees brought down to few cents now, something of that sort, globally it has come. But industries are really still reluctant to invest money because anything in the ocean is exponential cost. So let us see, even Lockheed Martin came to NAOT and they are trying to work on VOTEC. And these are all challenges they have.
One more, recently we have read on a news from Tamil Nadu government has entered for the deep ocean desalination and put together hydrogen separation and then going for a hydrogen cell, for which Tamil Nadu government is going to enter a MOU with the Sweden company.
Very good.
Can you throw some light on that?
Yeah, like this, various efforts are required now. Industry, academia, they all have to come together. Then only it is possible. It is not by a single organization alone. It has to be brought in with a different expertise. Definitely, I think we all should work together to succeed.
Similarly, the last one is about the drone, underwater drone you were telling. The main technology challenge lies with the communication, data transfer from the deep sea
Yeah,
below 2 kilometers down to the top layer. The communication by means of either which way you will communicate, by energy transmission or
yeah,
which way you can transmit. That is a challenge I have read somewhere. If that is overcome, part of propulsion of the drone using a heavy drag is another challenge which they have told. More of a drag, they consider the communication between the vehicle and the
yeah,
top layer is the concern. That's what I heard somewhere.
correct. Communication part, as I told you, underwater is only acoustic. The acoustic vertical communication, it's very well developed now. The acoustics horizontal is challenge. It's really attenuation is so high. There are also different thing about optical communication. Even there are people working on optical communication, transferring the technology. However, above water, we are using Inmarsat. Insat, we don't have much of footprint over there. Recently, I was instrumental in getting the government of India permission for iridium communication, which is widely used, it's a low orbiting satellite. We have got the permission from the government, and that we are buying the terminal and interfacing it, because the Inmarsat what we use is geostation satellite about concept 10 times more, and INSAT is much more higher. And INSAT also doesn't have two-way communication. We are also working with ISRO exclusively, like iridium type of thing, DRT and MSS system for our own oceanographic. Not only for us, it can be used for fishermen, many other applications. If that comes through, even recently, all the secretary of our secretary and ISRO secretary, they met. I had a series of meeting and submitted a detailed report to that. Soon, I'm sure that will be taken up. That will help us. So this is what is all about. But still, in the future, maybe 2050 or something, we need to develop a single mode by which from air to underwater direct communication. Currently, there's none exist like that. Yes, that's all we spoke about cable, talk about transferring the large amount of data. Conventionally, only kilobyte data could be possible. This is what is happening in the ocean side.
Good. Nice explanation. Thank you. Thank you very much.
Yes, sir. And I have a doubt on something, sir, on AUVs.
Balaji, can you introduce yourself first and then we can ask your question?
Oh, okay, sir. Yes, sir. I am Balaji from Mechanical Engineering Department of KLN College of Engineering. I just want to ask a question about automated underwater vehicles. I've come to know that there is no particular device to calculate the velocity directly, which was fixed inside the AUV itself. And how about the technology development and your future plans on it, sir?
So when you talk about velocity, these AUVs and systems are used for sometimes for accurate way of underwater maneuvering. When you talk about maneuvering, what they do, they got a different positioning system underwater. Again, they use acoustics. They have series of transponder deployed. For example, you want to survey a peculiar region using AUV. For location purpose, these we also use that. This is fitted to onboard the ship or on the seabed, and they communicate, and with that waypoint is properly maneuvered, and that is possible to be done. So this is a well-established field. There are companies like Sonadyne and Kongsberg. They are developing this AUV for such application. Other than that, for non-accurate applications, for general, for scientific purpose, whatever the current way of mode of maneuvering, and because you can always get from the position, and also with the current way of system over there, integrated navigation system INS, that is possible to be predicted and provide that. But like the chairman said, finally it boils down to how do you communicate to the surface. Unless you have a ship, acoustic communication picked up and transferred back to the shore. So this is what is a current channel. In the case of you spoke about glider, or this sailing speed or moving speed is not a sawtooth type. 0.5 knots, much slower compared to AUV.
So, any other questions from our members?
No, sir.
Okay. Chairman, sir, we can proceed next, sir.
Yeah, yes.
Congratulations to organizer. Holding on to 52 fellows till the end is tough. Normally the attendance drop down. Very glad.
Talk as well as presentation also is like that. That's why somebody asked you give your PowerPoint presentation so that we.
Yeah, I'll share.